The next point on the titration curve we're going to consider is the equivalence point. And the first question we have is, what is the volume at the equivalence point? Well, in the previous video, we calculated our moles, or I should say millimoles, of chloride was equal to 2.5 millimoles. It does have more significant figures than that, but we'll just leave it at 2.5. And so what we want to know, since our reaction is a 1-to-1 stoichiometry, that for every 1 mole of silver, 1 mole of chloride will react to form our silver chloride salt, we want the point at which we have 2.5 millimoles of silver, right? That they should be equal to each other. Okay, so we need to use the concentration that we know of silver to find this. So we know that it is a concentration of 0.05 millimoles per milliliter. And we write this upside down so that we can get units to cancel. And so we'll get 2.5 divided by 0.05. Let me pull out my calculator here. That is equal to 50. All right, so our equivalence point is at 50 milliliters. Now, when we're thinking about the concentration of silver, which is what we want to know at the equivalence point, it's useful to think of it this way. At the equivalence point, we know, by definition, that the concentration of silver is equal to the concentration of chloride. We've added a sufficient amount of silver to react with all of the chloride. And what we can think of this is that we've now turned it all into the salt. Now, some of it is conceptually, the way to think of it is some of it will then redissolve, right? All of this turned into a salt, but some of that salt is still soluble, a very small amount, and that'll be governed by KSP. So the concentration of silver and the concentration of chloride will be governed by KSP. And we can treat this like a problem that we did from our equilibrium chapter. We know that KSP, again, is equal to the concentration of silver times the concentration of chloride, right? With the way that we write the solubility product. And we know that these values are equal to each other. So we know that the value of silver and chloride are equal. So we can say that these are equal to x, and KSP is equal to x squared. And then we just need to solve for x, and that'll give us our concentration of silver. Okay, so again, KSP is 1.8 times 10 to the minus 10. Then we can just solve this. X is equal to the square root of 1.8 times 10 to the minus 10, which is equal to 1.34 times 10 to the minus 5 molar. Now you can see our concentration of silver has increased dramatically. It was 10 to the negative 9 in the previous video that we were looking at. We can see that very clearly in the p-value. So if we write PAG, that's going to be equal to, again, the negative log of this, base 10, of this value, and that is equal to 4.87. So just as a reminder, a lower p-value is a higher concentration. So we went from a p-value of 8.5 to 4.8. So several orders of magnitude change in this silver concentration once we're at the equivalence point.